Iodine refers to the chemical, so this lab will be utilizing iodine. The clock portion, one second, I'm going to turn the light on here. There we go. The clock portion refers to the predictability. So what we're going to be doing is changing the concentration of iodine, and that will change the amount of time it takes for a reaction to proceed. Now, in order to do this, we're going to need two different sets of solutions. The first solution we'd call solution B. Now, for solution B, you are going to be measuring out three different chemicals, and you are going to measure those out in a graduated cylinder. So we're going to draw one of those just so we remember. Those are our skinny, tall instruments used for measuring very accurate and very small volumes of liquid. And you are going to have several out and available to you. There'll be 2 or 3 on your lab station, but you're going to have some graduated cylinders, and you're going to have a beaker. It's not a big one. It's going to be one of the smaller 50 milliliter beakers. And into this beaker, you are going to put 3 different substances. The first substance you are going to put in there is sodium metabisulfite. And we don't need much of it. We need 4 milliliters. And the abbreviation, which is what will be on the bottle, is 0.2 molar, referring to the concentration. And the formula being Na2, sodium, S2O5, being that sulfite. So 4 milliliters of that. And then we are going to add, all of this is going into the same beaker, 12 milliliters of a starch solution, and it's going to be a 2% starch solution. Into the beaker. And then we're going to dilute this down, so we're going to top it off with 16 milliliters of water. Now, since all of these materials are going into the same beaker, it is okay to measure them out using the same graduated cylinder, or you could get a new clean graduated cylinder every time. It doesn't matter. But we know we are mixing these eventually, so if you use the same cylinder, that is okay. If you use a clean cylinder every time, that's all right. But what we should be left with at the end is a 50 ml beaker with approximately 32 milliliters of solutions in it. And this is going to, the whole thing, be called solution B. Now, after we make solution B, it is very, very important that you stop everything and clean. The portion of this lab, or the reason this lab is called a clock lab, is because we can accurately predict the time it takes to react. However, that accuracy is very dependent on having non-contaminated solutions. So after we make solution B, we want to stop what we're doing, and we want to clean anything that we use in step 1. And the only thing you should have used is graduated cylinders, but clean any graduated cylinders that you used. And we also do want to go ahead and clean 3 test tubes at this step. The test tubes are what we are going to put the next solution, solution A, into, and we want to make sure that we are starting with clean materials. Now, standard cleaning, you want to clean with soap and water, and you want to make sure that you get all the soap out. If at any point in this lab you see a yellow color, you'll know that your glassware wasn't clean enough. That is the sign that there has been some contamination. And you will need to dispose of what you're doing, re-clean, and restart that step. So do a good job here. Stop what you're doing, take 5 minutes up front, clean everything you're going to use. That way we can avoid this later on in the lab. We don't want to see any of that contamination, and if we do, we'd have to stop what we're doing and restart. Okay, so at this point in the lab, you should have a beaker called solution B, and everything should be nice, clean, and ready to go in order to set up the iodine portion. Now, we are going to be running 3 different trials in 3 different test tubes. In order to hold those test tubes up, we are going to use a test tube rack. You guys use the test tube racks in the zinc lab. So they're the wooden racks, you're familiar with them. And we are going to be using the larger test tubes. And we're just going to call them from left to right: test tube 1, test tube 2, and test tube 3. Now, into each of these test tubes, we are putting varying concentrations of solution A. So solution B, we only have 1 beaker of, but we have 3 solution A's. In test tube number 1, we are going to combine 5 milliliters of potassium iodate, the concentration of that being 0.1 molar KiO3, and 15 mils of water. And you can go ahead, you'll measure those straight in, you'll dump it into test tube 1, and we'll have a total volume of 20 milliliters. 5 potassium iodate, KiO3, 15 from water. Test tube 2, we're going to use the same chemical, but in a different amount. So in test tube number 2, we are going to put 10 milliliters of potassium iodate, and 10 milliliters of water. So the total volume stays the same. You can kind of check your work. All of these should be at the same level. 20 milliliters total volume of solution A, varying amounts of potassium iodate, which means varying amounts of water. And then for our final test tube, we are going to do 15 milliliters of this is my fault, that should be 0.1 molar. 0.1 molar KiO3. And since we still want a total volume of 15, this time we're just going to do 5 milliliters of water, or H2O. Now, so far, we have not done any chemistry yet in our iodine clock lab. We have just set up our materials. We've got solution B in a beaker. We have 3 solution A's and 3 different test tubes. The reaction doesn't start until you combine A with B. Now, we are not just going to bombs away dump all of solution B in test tube 1. Solution B is a stock solution. You have enough in this beaker to run all 3 trials. So what you're going to do is measure out 8 milliliters of solution B. So you're going to pull it from the beaker. And again, make sure everything is clean. You're going to put this into a clean graduated cylinder. If you're not sure if it's clean, just give it a rinse. And you're going to measure out just 8 mils of it. Then you're going to place that 8 milliliters of solution B into your first test tube, into your first solution A experiment. Now, once you combine them, you're going to go ahead and hit start on your stopwatch. So you're going to add your 8 milliliters of solution B into test tube 1. And the second you do that, you're going to hit start on your timer. and you're going to swirl it. Now, we're not mixing aggressively, but you are going to have 28 mils of liquid in here. Go ahead, you can take the test tube out of the container and you're just going to swirl it around in your hand. But you do want to swirl it so you get it nice and mixed. Then you're just going to keep swirling, or if you feel like you've really got it swirled, you can go ahead and put it down and you're going to wait. You are going to stop the timer as soon as you see a color change appear. And I promise it will be very evident. It will be a very clear color change, and it should happen, if you do a good job swirling, it should happen very quickly, very immediately. So you do want to make sure you're keeping your eyes on it. Then record the time in your data table. And we are going to repeat. So we have 3 different test tubes here. Test tube number 1, test tube number 2, test tube number 3. You are going to repeat steps A through C for tubes 2 and 3. So same thing. Get 8 new milliliters of solution B, put it in the test tube, swirl it, start it when you combine it, stop it when the color change appears. Make sure you're recording that time stamp each time. Now, if you're all done and you do it right, when you're completed with lab, you should have 3 test tubes that have transformed colors. You should also have some leftover solution B. I have you make a little bit of excess here because I don't want you to run out and have to remake it before that 3rd trial. But you should have 3 test tubes full of chemicals and some excess solution B. All of that can actually go in the same beaker up at the front. So for our cleanup, your test tubes plus excess solution B are going to be brought to the front and dumped into the disposal container. And they go into the same container. Okay? So, very straightforward lab. Only things to be aware of. So safety wise, we are going to wear our goggles. So we always do that. We want to protect our eyes. And then we do want to make sure we are cleaning up any spills right away. Tell your teacher, because we do want to get those up because iodine will stain. So if anything spills, tell your teacher right away and we'll get that picked up so that we can make sure that iodine doesn't get all over.